All right, we're going to take a look at questions T3.3 through 5. Scientists examined the activity level of 7 fish at different temperatures. Fish activity was rated on a scale from 0, no activity, to 100, maximal activity. The temperature was measured in degrees Celsius. A computer regression printout and a residual plot are provided. Notice that the horizontal axis on the residual plot is labeled fitted value, which means the same thing as predicted value. Okay, so let's just go ahead and make that change. All right, let's write this as predicted value. All right, question 3.3. What is the correlation between temperature and fish activity, right? So what is the R value? Okay. Well, we can see clearly here in the printout that the R squared value is 91%. Okay, so let's start with that. R squared is equal to 0.91. Okay. So we know that if we can unsquare this, right, then they would just get R. Okay, so R is approximately, okay, square root 0.91 is 0.954. All right, now at this point, let's not jump to conclusions. Let's not jump to the answer, because we've got to remember that when you take a square root, there's actually two types of square roots, right? Positive or negative. Okay. So how do we know whether the correlation is positive 0.95 or negative 0.95? Well, the correlation always matches the direction of the relationship, right? If the relationship is positive, the correlation will be a positive value, and a negative relationship, downward trend, would have a negative correlation. Okay. Well, we don't have a scatter plot, right? This is a residual plot. It essentially removes the direction from the relationship so that we're just looking at the form. So how can we figure out what direction the relationship had? And the answer here is look at the slope. Okay. Now this is our y-intercept right here. I'm going to label that as A. And this is the slope right here. Label that as B. So because the slope is negative, right, that reveals then that the relationship is negative, which means that our correlation would be the negative value, 0.95. Okay. All right, question 3.4. What was the actual activity level rating for the fish at a temperature of 20 degrees Celsius? Okay, so we could construct the equation, right? So predicted activity equals 148.62 minus 3.2167 times the temperature, okay? And then we can go ahead and use 20 as our input here, and we can get a predicted activity level, okay? All right, let's get that now. Duplicate that, and now just plug in 20 as the input value. And so the predicted activity level is going to be 148.62 minus 3.2167 times 20. I'm getting about 84.3. Okay. All right. Now there is an answer choice that says 84, but this is the predicted activity, and the question was asking about the actual activity. Okay. So I know that there's a relationship between the predicted activity and the actual activity, and that difference is called the residual. Okay. I'm just going to abbreviate here. Let's move our work up a bit. Okay. So the residual is equal to the actual value minus the predicted value. Okay. Well, we know the predicted value. Right, that goes there. The actual value, that's what we're trying to find, the residual. Hey, we have a residual plot, and maybe we can figure out the residual from this graph. Okay. Well, this graph is showing the residual versus the predicted value, and we just got the predicted value of about 84. So I'm thinking that that dot there represents 20 degrees Celsius, and so I think that the residual is going to be 2.5. All right, so let's use positive 2.5 as the residual. Actual value we don't know. Predicted value is about 84.3. Just solve for A now. 2.5 plus 84.3 is about 86.7. So A is approximately 86.8, sorry, 86.8. Okay. All right, there's an answer choice that looks pretty close. Like if we rounded that to a whole number, it would be 87. All right. Question 3.5. Which of the following gives a correct interpretation of S in this setting? Okay. All right. Now S, you can see in the computer output, is right here. This is something that we skipped over this year in class. We didn't talk about this statistic S. But S is the standard deviation of the residuals. Okay. Now look, some residuals are big, some residuals are small. So think of S as the average size of a residual. Okay. So S can be thought of as the average size of a residual. Okay. Or a better way of thinking about it, since a residual measures the difference between a prediction and the actual value, a residual is basically measuring the prediction error. So S is the average size of our prediction errors. All right, so looking at the answer choices, for every 1 degree Celsius increase in temperature, fish activity is predicted to increase by, that sounds like a slope interpretation, so that's not the right one. B, the typical distance of the temperature readings from their mean is about 4.785. Okay, so distance from the mean, that's standard deviation. Okay, that's not what we're looking for. Okay, we're looking for a statement that's talking about the average size of the residual or the average prediction error. Okay. All right, C. The typical distance of the activity level ratings from the least squares line is about 4.785. Okay, that one's promising. It's talking about the average distance of the ratings from the line. Right, so if we have this, that's way too many dots. Let's simplify that. Let's just have like a couple dots, 5. 1, 2, 3, 4, 5. Okay. So the distance from the line is basically the residuals. All right, so this is talking about the typical or average distance from the line. It's talking about the average residual. Okay. So I like C, but let's read through the rest of the choices. D says the typical distance of the activity level readings from their mean. That sounds a lot like B, so no. And E says at a temperature of 0 degrees Celsius, the model predicts an activity level of 4.785. That sounds like an interpretation of the y-intercept. Okay, so that's no good. All right, so C it is, right? Typical distance from the least squares regression line, distance from the line, those are residuals. So average size of a residual.